Okay, so graphing these by hand. We're not really doing much new here today. We're just kind of putting all together, getting more practice on this. This lesson, it's worth spending 2 days on. So just kind of review the steps. So when you're graphing by hand without a calculator, first thing is factor and find the zeros. Well, this one's already factored, so I'm going to find the zeros. The solutions would be set each factor equal to 0. So x equals positive 1, x equals positive 3, and x equals negative 1. So I'm going to put points there at negative 1, 3, and positive 1. So those are the three places that this particular function touches the x-axis. It doesn't mean it necessarily goes through, but it definitely touches at those three spots. Those are the only three spots it touches the x-axis for this function. So again, I didn't show my work, but you set each factor equal to 0 and solve. So x minus 1 equals 0. Solve it, you get x equals 1. Okay, step 2, do end behavior. So there's really four cases there of end behavior. So what I mean by that is you want to multiply this out if you FOILed this all out. Think about what the first term would be. All I care about is the first term. For example, x times x, if you FOILed that, would be x squared. This one, if you FOILed x plus 1 times x plus 1, x is being squared there. So x squared times x is x to the fourth. I don't know what the rest of the terms are, dot, dot, dot. But the key thing is that the highest degree term for this particular function is x to the fourth. That will determine its end behavior. So for this one, it's definitely going to be up, up, right? It's even and positive, so it's up, up. So on the rightmost point, it's going to go up and to the right. On the leftmost point, it's going to go up and to the left because the end behavior on the extremes as x goes to infinity or negative infinity is up and up, it's going up. The y-value is increasing. Okay, so then you want to look at, I think the best thing to do then is multiplicity of the factor. So one of the things you can see right away is this is an even, so this is an even exponent. This is exponent of 1, which are both odd. So this factor has a multiplicity of 2. Anytime a factor has a multiplicity of 2, that solution there at negative 1, it's not going to cross the x-axis. It's going to bounce up. Well, I'll tell you what I'm going to do. I'm going to make this step 4 here. It's really first get the intercepts here. So step 3, step 4 would be multiplicity. So let's get the intercepts. So to find the intercepts, you're going to set x equals 0 or y equals 0. We already found the x-intercepts. That's done. To find the y-intercept, to find the y-intercept, you're going to plug in x equals 0. Solve for y. So if you do that on this one, you get 0 plus 1 squared times 0 minus 3 times 0 minus 1. So we get 1 times negative 3 times a negative 1. Well, 1 times negative 3 times negative 1 is a positive 3. So I know it crosses that actually helps a lot. There, it crosses the y-axis at 3 there, which is super helpful. But let's look at multiplicity next. So multiplicity. So when I'm going to write it down here so you have it. So when you have an even multiplicity, the graph is going to bounce. It's not going to cross the x-axis at that point. So what I mean here is at negative 1, this is a multiplicity of 2. So there are two x plus 1s, x plus 1 to the second power. It's an even multiplicity. Therefore, when I cross that point at negative 1, which is where that point comes from, it's going to come up. And it kind of makes sense, right? We knew it was going to touch that y-intercept. It's not going to cross through at negative 1. But these other points have an odd multiplicity. They have a multiplicity of 1, which is odd, which means the graph is going to cross through. So it's going to come down and then come back up. Really, there's only one value, so step 5 is somewhat optional, but it kind of depends on the graph. Um, if you're not sure how far, so really like here, I don't know if it maybe only goes down a little bit, maybe it goes down a lot in between those points. I really don't know. So you might have to plug in a point or two, plug in a point or two. I don't want you plugging in a lot of points, trying to save you from that, but I'd pick a point between 1 and 3, so maybe 2 in this case. So if I plugged in 2, it would be y equals 2 plus 1 squared times 2 minus 3 times 2 minus 1, which is 3 squared is 9 times negative 1 times 1, which is negative 9. Wow, so it goes a lot further down than I thought. So I'm going to go and erase this piece. Um, so again, that's one of the points where it crosses. So it goes down to 2. We plugged in 2 for x to negative 9, so right about there. And it doesn't have to be exact, but now I know like it went down a lot further than I thought it was going to go down. And that's a pretty good graph of this. In fact, I actually graphed this, I think. Let's look at it, see what it looks like. So that's the actual graph. That looks pretty good. I mean, when you look at what we have, without using a calculator, we got our graph to look really, really good there. So let's try one. Find the relative min and max of the graph of the function. So this is, may not be obvious to you, but this is definitely a calculator question. So let's ask you to find the min and max of the graph. So we're going to use our calculator. And I'll let you use your calculator when you do this question. So we're going to go fx, go to graph page, type in negative x to the third plus 16x squared minus 76x plus 96. Okay, so we have a pretty good idea what the graph looks like there. Let's see, find the relative max and min. So you might want to consider, like I can't see, it looks like there's a minimum down there. I'm going to double click this value and go a little lower, maybe negative 25. I don't know. Oh, now I can see a little better view of this graph, which is kind of what I wanted. So it looks like it has a relative minimum around here and maybe a relative max around there. You don't have to view it in the same window, but it's just really handy to see the whole function. The end behavior looks to be up and then down at the end. It looks like it crosses at 2, 6, and 8. Look to be the x-intercepts there. But we don't have to guess at those points. We can use the trace feature. So menu graph trace, hit the right arrow key. Don't swipe, just hit the arrow key until you get there. The minimum looks to be that. Mouse to the right a little more until you get the maximum. And if you wanted to find the zeros, looks like there's one at 8 down there in the bottom right corner, one at 6, one at 2 as well. Okay, so find the relative min and max. So if they mean the relative min, so the relative min, whoops, let me get that so it stays. I could just grab that thing and move it in. Okay, so the relative min, because they're asking you for the value, it would just be the ordered pair, 3.57, comma negative 16.9. And the relative max, the highest in that area is 7.1, comma 5.05. If they ask for the min value, like we did last chapter, it would be negative 16.9. If they ask for the max value, it would be the k value of 5.05. That's the lowest and highest points respectively in that area of the graph. It's not the absolute minimum or the absolute maximum because this graph does go up forever here. It does go down forever. So those are not absolute minimums or maximums. They're relative minimums and maximums. Okay, let's try another one. Just kind of go through our steps here. So the first step is find the solutions. So x is already factored. X equals -1. I'm just going to color code it here just so we have something. So x equals 2. So that's this one. And this one is actually a factor, right? So that's actually x equals 0 if you set it equals 0. So 0. So we have 3 places where it touches the x-axis. That's where this graph is going to touch the x-axis. I would do end behavior next. So if you multiply this out, the first step, this would be x times x to the second power times x, which is x to the fourth, plus ... Don't care about the rest. X to the fourth is even and even, so up, up. So from the rightmost point, it goes up. From the leftmost point, it goes up. I would find the y-intercept now. So let's plug in 0 for x. So that would be 0 times 0 minus 2 quantity squared times 0 plus 1. So we get -2 squared, which is +4, times 1, which is 4. This looks a lot like our other graph, actually. But it does differ a little bit. So you notice that at this green point here, this one is to the second power. That's an even power. That's a multiplicity of 2, which means when it hits that green point, it's not going to go through the axis. It's going to bounce off, and it kind of makes sense because something's weird here. Let me double check something. Oh, I forgot to multiply by 0. This is not the y-intercept. So let's go back to this. Sorry. Sometimes you can catch your mistakes because they're so silly. Okay, so this is 0 times this. So 0 times 4 times 1. 0 times 4. 0 times 4 is actually 0. So the intercept is actually, we already have the y-intercept. I should have seen that. Y-intercept is 0. I forgot to multiply 0 by everything. So 0 times I wrote it out and I didn't multiply. Okay, so going back to the green point here. So at that point, it's going to bounce off, which means it's going to go back up. Now, I don't know how far it's going to go up. It's got to hit this next point. It's got to touch right there at the red point. And at the red point, this graph is has an odd power. Same thing, odd multiplicity for both of those points. It's going to go through and go through there. So I think that's a graph of our function. You might want to check a couple other points. So the one that seems obvious to me, like there's not a whole lot of distance between 0 and -1, but between 0 and 2, so I might plug in x equals 1 if I were going to plug in a value. So I do that. Let's see if I can do this right this time. 1 times 1 minus 2 quantity squared times 1 plus 1. So we get 1 times -1 squared is 1 times 2, which is 2. So, oh wow, that was fortunate. I guess. I just kind of drew a random line there. I didn't know how tall it go. I plugged in 1, I got 2, so that's the ordered pair 1, 2, which is that point right there. I'm pretty happy with this graph. You could plug in -1/2 if you wanted to make it even better. I'm not sure what this graph looks like. I don't think I have a graph of it. We could graph it just to see how we did. So let's see. So x times, let's see, x minus 2 squared times x plus 1. And that is what it looks like, isn't it? I mean, we went a little bit kind of wide on the purple part there, but it's pretty much a W that's kind of offset kind of W there. That's exactly what this graph looks like. Okay, I think that's enough for today. We're just, again, it takes a while to get used to doing all this to graph a function. So I hope that helped, and you can do your homework.